When a storm rolls in, it arrives in two distinct waves. First, a jagged streak of light shatters the sky, followed by a deep rumble that rattles the windows. The light is the raw electrical discharge. The sound is the physical shockwave trailing behind it. This energy originates within the cumulonimbus cloud. These massive formations are towers of moisture that can stretch 18 kilometers into the atmosphere. This diagram shows the formation process. Sun-heated moist air rises rapidly until it hits an invisible ceiling called the tropopause. Blocked from further vertical growth, the air spreads horizontally, creating the cloud's signature anvil shape. At this scale, the cumulonimbus operates as a massive floating battery. This enormous structure uses nothing but water and air to generate millions of volts of electricity. The charging process begins at the top of the anvil, where temperatures drop as low as -40 degrees Celsius. In this extreme cold, water exists in two states simultaneously: tiny ice crystals and supercooled liquid, water that remains fluid even well below the freezing point. Violent atmospheric updrafts force these states to collide. When supercooled liquid hits an ice crystal, it freezes instantly, forming a heavier, frozen structure known as graupel. During these collisions, lighter ice crystals strip positive charges and are swept to the cloud's top. The heavier graupel retains negative charges, sinking to the bottom. This internal friction polarizes the cloud, creating a distinct electrical divide: positive anvil, negative base. The cloud's negative base pushes Earth's negative charges underground, leaving a concentrated positive surface. This intense tension pulls them together across the air's invisible insulating barrier. When voltage overwhelms this barrier, a negative stepped leader descends in jagged jumps, meeting a positive upward streamer. The moment these two paths meet, the circuit is completed. The air breaks, releasing a catastrophic strike of pure energy. That blinding white flash occurs because the electrical surge superheats the air to temperatures hotter than the surface of the sun, stripping electrons from oxygen and nitrogen molecules. This creates a column of plasma, the fourth state of matter, which glows with intense blue and white light. The thunder follows as the plasma expands violently and then crashes back into the surrounding cold air, generating a massive shockwave. This explains why we hear a prolonged rumble. Because the lightning bolt is a jagged path miles long, sound waves from the top take longer to reach your ears than sound from the bottom. These waves arrive at staggered intervals. The terrifying light and sound are the physical byproducts of the atmosphere aggressively balancing its internal electrical equation. Despite its destructive appearance, this electrical discharge is an ecological necessity. The immense heat of the strike breaks apart atmospheric nitrogen bonds. This allows the nitrogen to dissolve in rain and fall to the earth, acting as a vital fertilizer for the planet's soil. The cumulonimbus cloud is a natural engine. The tension it creates is a fundamental process that keeps the Earth's ecosystem alive and thriving.